Okay guys, this is a vacuum tube Tesla coil. You can see there's a pair of tubes there. They're 833C transmitting triads, and they're rated at roughly 3 kilowatts. Okay, now the whole thing's fed off a 6,000 volt power supply. Come around the back. You can see here we've got a 3,000 volt plate transformer, and it's fed through a voltage doubler, which consists of a pack of capacitors there and a high voltage diode. There's also a pair of caps there which provide protection for the high voltage diode so that it doesn't blow up. We've got a 12 volt toroidal there, and what I do with that is I run that through a variac, and that needs to be ramped up to 10 volts AC, because I need a 10 volt AC 10 amp filament supply for the tubes. Okay, around the front we can see that the tube coil itself, or the driving part of the tube coil, consists of a primary coil, and I think that's roughly 35 turns from memory of 2.5mm built-in wire, capacitor bank, and the tubes which provide the switching. We have a tertiary coil here, sometimes called a tickler coil or a filament coil, and that's also driven from the primary. It provides a feedback voltage to the tubes, and that modulates the tubes. These are triads, so it's a 3-component tube. We've got plate, you've got the cathode and filament, and you've also got the grid, and it's the grid that's being modulated by that, and that's what switches the tubes on and off. For a Tesla coil you need to provide a pulse current to the primary, and that induces a resonant voltage rise in this secondary coil, which is 950 turns on a 3.5 inch PVC, I should say. Right there, so I can measure my filament voltage easily. Make sure it's turned right down, turn the filaments on, and slowly ramp them up to 10 volts AC. That extends the life on the filaments. If you ramp them up slowly, and then let them warm up for a good 5 minutes, and let the voltage on them stabilise before you run the coil, you'll extend the life of the tubes enormously. 6 volts, 7, 8, 9, slow it down. And additionally, I'll run it a very small amount over 10 volts. And the reason for that is when the coil's running, it's drawing 30 amps from the wall, so it's going to drop the wall voltage a little. And the one thing we don't want to do is let the voltage on the filaments drop below 10 volts, because that will damage the tubes. So I'll let it sit at 10.06, and we'll just let them sit for probably 5 minutes to warm up. And just keep an eye on the variacs play. This can run any sort of coil, right up to a high power coil. You can see here, I'm just pulling some papers out here. This is actually a dual variac supply. That's a big 32 amp variac. That's what runs that. And there's a smaller one here, it's a 10 amp variac, but for this application I don't need it. So I just have it set on 240 volts. For some coils, like spark gap coils, I often use a type of spark gap which I call a sucker gap, and that's basically a vacuum tube motor connected through the two metal pipes, and the spark gaps across the pipe, so you suck air through the pipes and it quenches the spark really quickly, and that's what you want. You want fast quenching. That's why we're using tubes here, by the way. Fast quenching, you need to switch it on and off very, very hard so that you get the resonant rise in a Tesla coil. And it's the biggest thing you need to pay attention to, is to get a good switch on, good switch off, nice and hard. Transistors, it requires a bit of work to get them to do that, and you can see from that thing down there how much more complicated it does get. The amount of electronics is like doubled, tripled in order to be able to do it with transistors. Yeah, so yeah, I have that set to 240 volts, and that runs into my filaments and fans. and the filament supply can then be controlled by the small variac on the front there. Fans just run at full voltage. I've got a little dimmer on them, but that's as good as pointless. I may as well take this as a hard vacuum.
Ah, it's a hard vacuum, there's no gas. Ah, right. There's no air, nothing.
No. That's why the getter's in there. It's to remove, the getter's in there to remove all last traces of air in the tube.
So they have to handle the atmospheric pressure just by the shape of the valve. Right. It's really nice and thick.
Yeah, it's thick glass.
Yeah.
And you can see the connections are well sealed.
But it's like a CRT television.
Yes, it's the same. It's the same principle. You want thermionic emission of electrons. They're very similar to what's happening. Now we'll do a full power run to start with. And I'm going to ramp it up very slowly because I've just put that winding back on and I just want to make sure it doesn't run as low as possible. Okay, we're getting output now. And we're getting output at that's about 50 volts in from mains currently, so it starts to break out at about 50 volts. We've got 100 volts in now. 150. 200. 240. Up to 270. We're not hitting the breakout point, but that's cool. I might lower it a little bit for the next run. There we go. Have a look down at the tubes, see how they're starting to glow red. The plates, if you don't know what the plates are, have a look at the plates, you can see they're starting to glow red in the centre. Okay, I'll stop that. I'm going to see if we can't get it to hit that plate a little bit more. It scares the life out of me if I turn it on, it's at full output. That's probably not too good for the tube coil either. Okay, ramping up. That's better. Those tubes cool off a bit. They're getting quite warm, as you can see they're glowing nicely now. Okay, let's try a pulse run. That'll cool the tube down a bit too. Okay, let's start with a low pulse. You hear when it crackles? There's some points in between where this doesn't lock into the zero voltage. I've got to avoid those because that's when I get arcovers. It's not switching properly. Okay, this is the low pulse rate. Turning it up. Turn it down in between because of those in between points that don't want properly. Hear that correctly? Yeah, we'll avoid that. Let's try that. I see you jump every time that hits the target. Quite a good snap, huh? Yeah, a bit faster.
And it's a jet black in the background. And no reflection from anything.
Ramp it down through the levels again, and we'll go for another full power run. As low as we can go. We've got 1 pulse a second. And that's generating a huge EMP burst every time it does that now. Full power again.
Oh yeah, I got that one.
Where did that arc?
Down in there, yeah.
Nasty.